Hi and welcome to Trig Formulas Day 7. Today we are going to be doing the same thing we were doing before, except now we're adding double angles to what we're dealing with. So let's get started. For number 1, I have sine 2 theta cosecant theta equals 2 cosine theta. Well, sine 2 theta, I've got a formula, and it is 2 cosine theta sine theta. And cosecant is 1 over sine theta. So when I multiply, those two sine thetas cancel each other out, and I'm left with 2 cosine theta. And they match. Cosine, for number 2, cosine theta minus sine theta squared equals 1 minus sine 2 theta. Well, that means write it twice. So cosine theta minus sine theta times cosine theta minus sine theta. I'm going to need a FOIL, so cosine times cosine is cosine squared theta. Cosine times negative sine is negative sine theta cosine theta. And then I'll have another negative sine theta cosine theta plus sine squared theta, because sine theta times sine theta is sine squared theta. So when I combine like terms, I have cosine squared theta minus, I have 2 sine theta cosine thetas plus sine squared theta. Now if I do a little bit of rearranging here, I have cosine squared theta plus sine squared theta, and I get 1 when I add those together, minus 2 sine theta cosine theta. And I'm very close to what I need, because 2 sine theta cosine theta is 1 minus sine 2 theta. So now I match. All right. For number 3, we have cosine 2 theta equals 1 minus tan squared theta over 1 plus tan squared theta. Since I have 3 different formulas for cosine of 2 theta, I'm not going to work with that side first, because I don't know which formula I need or which form I need it to be in. So I'm going to work with the left side first, or sorry, the right side first, and turn everything into sine and cosine. So it's 1 minus tangent is sine plus cosine. So it's sine squared theta over cosine squared theta all over 1 plus sine squared theta over cosine squared theta. Now I have a complex fraction. In order to get rid of my complex fraction, I need to find an LCD, and my LCD is cosine squared theta. So I need to multiply everything by cosine squared theta. And when I do that, I will get cosine squared theta minus sine squared theta, because here that will cancel out with the second one, over cosine squared theta plus sine squared theta. And cosine squared theta plus sine squared theta is equal to 1. So I'm left with cosine squared theta minus sine squared theta over 1. And cosine squared theta minus sine squared theta is cosine 2 theta. And now they both match. For number 4, I have 1 plus cosine 2 theta over 1 minus cosine 2 theta equals cotan squared theta. Sorry about that. I'm actually going to start with the right-hand side. Cotangent squared theta is going to be cosine squared theta over sine squared theta. Again, because I don't know which formulas I want to use for cosine of 2 theta, I need to look at the other side first to kind of guide me. On the right-hand side, I have a cosine in the numerator and a sine in the denominator. So what I want to do is change everything to cosine in the numerator on the left and sine in the numerator on the left. So I'm going to have 1 plus, if I use the cosine double angle that only has cosine, it is 2 cosine squared theta minus 1 over, if I do the formula that only has the sine in it, it'd be 1 minus 2 sine squared theta. In the numerator, my 1's cancel each other out, and I'm left with 2 cosine squared theta over, distribute my negative, I have 1 minus 1 plus 2 sine squared theta. And then here my 1's cancel each other out. So I have 2 cosine squared theta over 2 sine squared theta. I'm sure you can see where this is going now. My 2's cancel each other out. So I am left with cosine squared theta over sine squared theta, which is cotangent squared theta, or the fact that we already changed it, doesn't really matter. And that's it. So when you're dealing with double angles, you just need to be sure with the cosine that you work with the opposite side of the proof first, kind of see what you need to get in terms of, and then pick your double angle carefully. All right.